In today's video, I'll be going to give a short introduction to analysis of variance, also known as Anova test. We shall go through how to perform an Anova test by hand first before using R for computation purposes. So let's begin. In short, Anova test is just an extension of the t-test that you normally do for hypothesis testing, but in this case, there will be more than two groups that we conduct the test on. When using a t-test, we have two groups, and then maybe we want to test whether there's a differences in the means between the two groups. As for Anova test, we can have more than two groups, and so let's say for our example, we have three groups, and for the context of the test is the people's willingness to invest on a scale of 1 to 10 now in the normal days, during a recession, group 2, and after a recession, group 3. So in this example, we see that in each group there are different level of willingness to invest, and we want to test whether there's a difference in the average willingness between the groups. So for our null hypothesis is that all of the three means are equal, and for the alternative, we have at least one group having a different meaning willingness. So what we want to measure is the difference between each category, and we can think of these differences as an impact. So it's like how impactful one of the means is compared to the other. And so there are two forms of variance which can affect the overall impact within the groups and between the groups. One of the variance is the one within the groups. So you can think of the impact within this group first, and then the other variance is the impact between the groups. So it's like how this group mean differs from this group mean, which affects the overall impact. And so to measure the variance within the group first, so let's say for example group 1, we'll need to calculate the sum of squares within each group, which is then we need to find the mean and then take the difference between each of these observed value with the mean. Afterwards, we'll square each of these value and then add them together. So you can see I've already computed 2 minus 4 for the group 1, then I minus off each and of the 5 participants, then I add them together. But I'll also need to do so for group 2 and group 3. And after adding everything, this is called the sum of squares within the group. Now we need to measure the next part of the variance, which is the sum of squares between the groups. So we need an overall mean first, which is to treat these data sets as one big data set and compute the mean. And then now we just need to take the mean from each group minus off this overall mean and square it. And then since there are 5 participants in each group, we just take that value after we add everything together and we multiply them by 5. It is that simple to calculate the sum of squares between the groups. Now, for our calculation purposes, this sum of squares is how impactful it is. And we need to calculate the average sum of squares between and within the groups. These are known as the mean squared within the group and the mean squared between the group. And the formula goes as follows. For the mean squared within the group, it is equal to the sum of squares within the group divided by the degrees of freedom within the group. For the degrees of freedom, it is possible that there are different number of participants in each group, but in our case, there will just be 3 groups, and so we can just take 3 times 5 minus 1. If it wasn't this case, we will just take the number of participants minus 1 in each group and then add them together. For the mean squared between the group, it is a similar formula, which is the sum of squares between the group divided by the degrees of freedom between the group. In this case, because there are 3 groups, you just take 3 minus 1 for the degrees of freedom. And so with these two values, now we calculate the F ratio, also known as the F statistic. This F ratio just takes the mean squared between the groups divided by the mean squared within the groups, and you compute it and get this value. Lastly, we just compare it with the tables based on the given degrees of freedom in the numerator and the degrees of freedom in the denominator. In our case, our numerator has a degree of freedom of 2 and our denominator has a degree of freedom of 12. 5 minus 1 times 3. And so we can look at the table 2, 12, 5.96. And since our F ratio is greater than this significant rejection value, we can just reject H0, and so we can say that the means do differ. And thus, the willingness during or after a recession is different from a normal days. Yeah, and that's all for understanding the Anova test. So with our understanding now, we understand how R can compute it, which follows the same step, but since it's a computer, it does it much faster. So let's see now how an Anova test can be computed in R. For R, we first import the data sets, and in my case, I've imported a data set from the internet about the effectiveness between 3 types of fertilizer and the crop yield. So I imported the data set, and we can see that different fertilizers yield different results. To perform the Anova test, you just use the function AOV bracket the yield tilde the factor bracket the fertilizer. This factor is to tell R that it is categorical and there are 3 factors inside. And yep, R will just help compute all the calculations that you need. And with my short introduction earlier, you understand what does this sum of squares mean, mean of squares, and the F value, how is it all computed. They will give you the P value, which you can easily then determine that is less than 0.05 or less than your significance level, so that you can reject H0 accordingly. Yep, and that's all for today's video. Thank you for listening. Please like, share, and subscribe, and leave any comments in the comment sections down below. Thank you.